right, for section 4, we're going to be talking about angles, and I'm not talking about like how to classify angles as like acute, obtuse, and right. Okay, we probably already know how to do that because you guys have all had geometry already. What I'm going to talk about today is angles on the coordinate plane. So on that XY axis, how we can draw angles on there, whether they're positive or negative. And we're going to talk about two different types of angles. We're going to talk about coterminal angles and reference angles. So first, I just want to go over what angles look like on the coordinate plane. And another way that this is sometimes used is in like science. They might talk about vectors, okay, and like kind of the direction that a vector goes in. And that's just demonstrating the direction something's traveling in and like how fast it's going. So that's kind of where these angles in the coordinate plane come from. So an angle in standard position has its vertex at the origin. So if I think about my graph, your origin would be right there in the middle at 0, 0. So a standard angle would have its origin or its vertex right there. Remember, the vertex of an angle is like where it starts. Okay, that's right where the two rays that make the angle meet. Now the initial side is going to be on the positive x-axis. So that would be from the origin going off to the right side. That would be called the initial side. The other side then of the angle, the other ray, that kind of forms what the angle looks like. So this can change depending on how big or how small of an angle we have. That's called the terminal side. Okay, now for example, this angle, if it's starting in standard position, that's kind of starting at 0. It's like flat against that x-axis, and then it got rotated counterclockwise to the left. So that's the angle that we're looking at there, and this could be any number. So I mean, they could say this is 120 degrees. Or they could say it's 105 degrees, or whatever it might be. Okay, you could also have smaller angles, so it doesn't have to necessarily be that big. So just another example. It'd be something that looks like that. And you still have those same pieces. You still have that bottom being the initial side, because it's along the x-axis. And then you have this side being the terminal side, because that's where the angle went to. And so this one would be a little bit smaller. We could say that maybe this one's 50 degrees. The thing to know about angles here is that if they are positive angles go counterclockwise. So think about your coordinate plane. There's 4 quadrants to them. It starts in that top right corner, and then it makes like a C. It kind of goes around counterclockwise when we call 1, 2, 3, 4 when we're talking about those quadrants. Okay? Negative angles rotate clockwise, so they go the opposite direction. So instead of making like that C shape, you're going to go the opposite way. You're going to go clockwise around the coordinate plane. Okay, so for example, if we had a negative angle, it might still look the same as far as where it starts. So you're still going to have that angle in standard position, so it's still going to have its vertex at the origin. It's still going to have its initial side along the x-axis here. But this time, if they had labeled it, so this is still the terminal side, if they label the angle measurement inside, or if you're told that this time the angle is negative 110 degrees, that's because it went the other direction. Instead of going around the quadrant like we normally do, it went the opposite direction, and that causes the angle to become negative. So most of our angles that, like when you guys first talked about angles in geometry, you talked about acute angles, right angles, and obtuse angles. You probably didn't see anything more than 180 degrees because that's a flat line for an angle. Now in here we're going to be talking about more than that because we're talking about rotations. If I take something, I can rotate it all the way around. Like think about your tires on your car. Okay, they have to go 360 degrees around continuously, or your car's not going to do you much good if your tire only goes half the direction and then it stops. Okay, so we're talking about these angles that can continue to rotate around this point. So these are known as like multiples of 90 degrees. If we think about our quadrants, we have 4 quadrants in there. So I'm going to show you a couple of examples here. The graph gets set up the same way. Okay, you've got 0 degrees would be here, 90 degrees would be up at the top, 180, 270, and then back at 0 would be 360. So a lot of times you'll see that first piece being known as the 0 degree mark and the 360 mark, because if something completely rotates 360 degrees, it made a circle. It went all the way around the graph. So you can see angles doing any movement. It could go anywhere from 0 to 90 degrees. It could go from 0 to 180 degrees. It could go from 0 to 270 degrees. And it could make that complete circle. Okay, so all of those are talking about a different type of rotation depending on what you're doing with the shape. So for example, if they wanted me to draw an angle that was 270 degrees, then I would have it go all the way. I would follow like the orange line there, and it would end up being along that y-axis. So when they give you an angle measurement of some type out there, you have to think about on the quadrant, where would it be? And if it's not on one of the axes, then you would say, well, which ones is it between? Which quadrant am I going to? So if they wanted me to graph something that's 300 degrees, then what I would do is think about, okay, I start at 0, I go 90, 180, 270, and then all the way back around would be 360. So I'm not going all the way around, but I am going over the 270 mark, so I'm going to be in quadrant 4, and at this point, I'm not expecting you guys to be perfect with your angle measures. You're just going to have to estimate where you think that would be. So that would be my terminal side, and so I would label this as starting from here at 0, going around to that terminal side. That's probably about 300 degrees. And like I said, I do not expect these to be completely accurate, where you know exactly where 300 degrees would be or 310 degrees would be. As long as you're in the right quadrant, I'm going to look at that and see that you had an understanding of where it should have been in kind of the general area. Okay, so let's do one more. Let's say they want me to graph 150 degrees. You're going to start all of these in the same position. So you can always draw that initial side to get started. What quadrant do you guys think 150 degrees would be in? The second one, because the first one goes from 0 to 90. The second one goes from 90 to 180. So I'm not going to go all the way to 180 because that would be a flat line. I'm going to be a little bit above that. So it's going to be in second quadrant somewhere. And this angle here would be 150 degrees. Now we're going to see some other angles here today that are negative. And if they're negative, you just have to kind of reverse your thinking. You got to go backwards. So if it helps you to think about, okay, I'm going negative 90, negative 180, negative 270, it kind of just flips that whole circle around. You can do that. We'll also see some angles that go over 360 degrees because maybe something got rotated more than one time. Okay, maybe it goes over 360 because it made a circle and then it kept rotating a little bit more. So we are going to talk about how do you draw all of those types of angles today. So I want to first start with a negative one. So they just want us to graph the angle on the coordinate plane here. So draw that standard or that initial side. That's along the x-axis there. Now if I'm going negative 60, I have to go the opposite direction. So I'm not going counterclockwise, I'm going to be going clockwise. So I kind of reverse my thinking that, this is like 0 degrees here. This would be negative 90 degrees if I'm going clockwise. So I'm going to be down there in quadrant 4 because I'm going the opposite direction since it's negative. So I would just draw a line down there wherever you think 60 degrees would be about. And then you could label it. This is negative 60 degrees because I'm going clockwise. So on the next page, why don't you guys try number 2? You're trying to go negative 225 degrees. So if it helps you to label it this way, you're going the opposite direction, so we're going backwards. So I've changed, like, my 270 and my 90 have flipped places because I'm going clockwise around this graph. So it's changing the way that my numbers sit. So then for negative 225, if that's what I'm trying to graph up here, it's going to be somewhere in between negative 180 and negative 270. So I had mine within quadrant 2. And then I always label it so that the reader knows which direction I went. So I start here at the bottom of that initial side. I went clockwise until I hit that terminal side, and that's negative 225 degrees. So let's talk about what do we do if we go over 360 degrees. So number 3, it's at 900. 900 degrees. So that's going to be going around my quadrant a couple of times because that's well over 360 degrees. So what I like to do is think about, each quadrant is broken into 90-degree sections. So I like to figure out, how many of those quadrants am I going to have to pass through to graph this angle? So what I like to do is take my number, if it's over 360, and I like to divide it by 90. Because each quadrant is 90. What would be 900 divided by 90? 10. Okay, so this means that I have to go through 10 quadrants. So I'm going to go around the quadrants until I get to 10. So I'm still starting at the initial side. And this is positive, so I'm going to go counterclockwise. Okay, so let's just do a quick count. Here's 1, 90 degree, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to end up laying flat against that other axis, like going the opposite direction of my initial side. But I'm going to draw this angle in and show all of those rotations that it does. So let's see here. I'm going to draw it out. It's going to end up coming this way. But what it did is it started here and it went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Before it finally landed there. So this would be 900 degrees. So you're going to want to show when you label how many times did it turn, because that's going to let the reader know how many times this thing rotated. So this rotated 2 full times and then another halfway. It didn't quite get all the way around for a third full rotation. It went about 2.5 rotations around the coordinate plane there. Why don't you guys try to graph number 4, 225. So we had negative 225 earlier. Now I'm doing positive 225. So you should have gone counterclockwise. Which quadrant did you end up in? 3? So this is positive 225. So positive and negative angles are going to look different. They're not going to look the same because you're changing which direction you're going around the coordinate plane. All right, so why don't you guys on the next page there's 5 and 6. The first one's negative 600, and then 6 is positive 600. I want you guys to try to do both of them. So what I would do to figure out how many times you're going to be moving this is I'm taking them divided by 90. Now, some of you are doing it divided by 360, and that's fine if you want to think about like a full rotation. Since you know that 600 is over 360, we know that it's going to go around, not a full time, because 360 twice would be bigger than 600. So if you took 600 for both of these divided by 90, since they're the same amount, you're just changing the direction that you go in. They both come out to be 6.6 repeating. So that means you're going to go into 6 of those quadrants, and then you're going to go into almost a full quadrant, but not quite, because it's like about 2/3 of a quadrant there. Now for the first one, negative 600, which direction do I want to go? Clockwise or counterclockwise? Good, clockwise, because it's negative. So it's going to end up being in quadrant 2, because if I follow my path here, here's 1, 2, 3, 4, 5, 6, and then it's got to go a little bit more into that next one. So this is negative 600. Positive 600 is going to look very similar. It's just you're going the opposite direction. So you're going to end up down in quadrant 3 because this time you're going counterclockwise. So you're still going 1, 2, 3, 4, 5, 6, and then a little bit more, and that's positive 600. Like I said, if you're doing divided by 360 instead, 600 divided by 360 is 1.6. So you make a full rotation, and then you do 2/3 of another full rotation. So you'll have to think about what that looks like. That's why I divide by 90, because that tells me that 6 tells me how many quadrants I have to pass through. Okay? All right, you feel okay about drawing those types of angles? Just be careful with which direction you go, if it's positive or negative, whether you're going clockwise or counterclockwise, because it does matter. I mean, those look different. So it would matter if you went the wrong direction. All right, so coterminal angles are angles that are in standard position with the same terminal side, and they're always multiples of 360 degrees apart. So an example of this would be if I had an angle at 300 degrees and an angle at negative 60 degrees, they're going to look the exact same. They're a full rotation apart from each other. So if I think about my graphing here, if I did 300 degrees, starting it in standard position, that would be down here in quadrant 4, because if I go this way around the angle, that's 300 degrees. The negative 60 would be going the opposite direction. So those two together, if I look at their difference, if I take 300 minus negative 60, I get that 360, which is within the same rotation. So these would be examples of coterminal angles. They have the same ending point. So that co is just talking about you've got more than one angle and they have the same end result. They look the same, but they represent one's positive and one's negative. So in order for us to find coterminal angles, not necessarily graphing them, but just if you're given a measurement and you want to find a coterminal angle, you have to go either like more than 360 or less than 360. So if I'm given 150 degrees, the rule is to add and subtract 360 degrees from that angle to get me on both sides of it. So I would take 150, I would add 360 to that, and that would come out to be 510. And then I would take 150 and subtract 360, and that would give me negative 210. So these would be two coterminal angles. If I graphed both of these, they should end up in the same spot. Now, when they say to find a positive and a negative, they are looking for one that has a positive sign and one that has a negative sign. So let's say you have an angle and you're trying to find the negative one. Let's say you subtract by 360 and you still have a positive answer. You need to subtract 360 again to get to a negative answer. So if you only are subtracting and you're only getting positives, you have to keep subtracting until you finally get your negative. And most of the time, that means that you subtract like twice. It's really rare that you have to subtract 3 or more times. And if you do, you're probably dealing with a really large angle to begin with, a really big rotation. Okay, so try A and try B. Find a positive and find a negative coterminal angle with those two. So for part A, you should have been able to add and subtract 360 and get those two angles that you need because you get positive 400 and negative 320. Now for part B, when you add 360, you get 740, so that's fine. When I subtract 360, I got 20. So that's not negative yet because it does say up here a positive and a negative. If they didn't specify that they wanted a negative one, then I wouldn't have to worry about this. But since I got positive 20 here, I had to do it a second time. I had to subtract 360 once more to finally get negative 340 degrees. So that's that case I was talking about a little bit ago, that if you don't get a negative the first time you subtract, you have to subtract again to get to that negative side. And if you have to subtract more than twice, you can do that too. It just depends on how many times you have to do it until you get to a negative number. Okay, the last type of angle I want to talk about is reference angles. So reference angles are positive acute angles. So all of these are going to be less than 90 degrees. So if you get a reference angle that's greater than 90 degrees, then we did something wrong. Okay, so then we have to go back and try to reevaluate that. It's formed by the terminal side, so the ending side of your angle, and the closest x-axis. So what they're going to want you to do is find reference angles based off of the angle that we have on our plane. So if you need to graph these first so that you can kind of visualize which x-axis it's closer to, you should start there. So like for number 1, they're giving me the angle of 150 degrees. So I'm going to start by graphing that one first. So your initial side is still going to be in the same position. Think about this is 150 degrees. So it's not going to be all the way to 180. It's going to be in between 90 and 180 on my graph. So we're going to be in quadrant 2. So I'm going to draw my line here, kind of estimate where I think 150 degrees would be. So the reference angle is going from that terminal side, so the side that's in quadrant 2, down to the nearest x-axis, and it has to be an acute angle. So I'm not going to go back to its initial side because that would be 150 degrees. 150 degrees is not acute. Okay, that's obtuse. So I want to figure out how much is left to get down to that x-axis there. So if I'm at 150, you guys know that a flat line is 180. What's left between 150 and 180? 30 degrees. So that would be the reference angle. So you could take that 180 and subtract 150 to get your 30 degrees for the reference angle. Okay, you guys try to do number 2. Graph 280 and then figure out how much is left in between the terminal side and the closest x-axis side. So that's what 280 looks like. To get to the closest x-axis, we want to kind of finish up this rotation. So I want to figure out like what's left between that terminal side and doing a full rotation of 360. So I would have taken 360, subtracted that 280 to figure out how much is left, and that would be 80 degrees. So 80 degrees would be my reference angle. Now let's talk about if we go to a negative angle. So number 3 is looking at negative 130 degrees. So let's start by graphing that one first. Switch your direction now because we're going negative. So we're going to have to go clockwise. So think about negative 90 and negative 180. So I'm going to be in this area. So this is negative 130 degrees here. The closest x-axis would be to still get to that 180. Now, all of your reference angles have to be positive. So if you need to think about, if I'm at negative 130 and I'm trying to get to negative 180, you can still think about there's a 50-degree angle difference there, but I also have to make sure that it becomes positive, so you just want to switch the sign. Think about like you're almost doing an absolute value of it. So that angle is going to be 50 degrees. All of these need to be positive. Even if you're dealing with a negative angle to start with, your reference angle should still be positive. All right, these last couple here. Number 4, it starts with an angle that's over 360. So what you could do is actually find its reference angle, or its not its reference angle, its coterminal angle. We could take 560 and subtract 360 to get something down to a little bit smaller. What is 560 minus 360? Who knows what that is? 200. So I'm going to graph an angle that's 200 degrees instead, which would look something like this. Okay, so let me ask you this question. That terminal side, which x-axis is it closer to? Is it closer to like the negative x-axis or the positive x-axis? It's closer to the negative x-axis for this one. Because if you think about where the negative one is at, the negative one is right here. There's smaller space here, and that's the acute angle. If I go all the way over to this one, that's an obtuse angle. So I don't want to go that way. I want to think about what was left to go from here to here. So that flat line is 180 degrees. So what's the difference between that 180 and the 200 that I'm at? 20. So this angle is the angle that I'm looking for. That's going to be 20 degrees. This last one is negative 25. So that would be about there. That's 25, negative 25 degrees. Which x-axis is that one closer to? Positive again. Well, positive for this one, so you're going backwards. So you're just kind of thinking about what's the space here, which we know that we went negative 25, so it has to be 25, because that's how much space to get back to that flat line. And it has to be positive because all of our reference angles have to be positive.